Hi everyone, this is Mrs. Leong and I'll be going over 7.5 properties of logarithms. All right, so the main focus of this lesson is just to get comfortable with these three properties regarding logarithms. So the first one tells us that when you have a log and you have the argument, that's a product, you can split up that log to be log A plus log B. And each of these will have its own log with the same base as the original log. So again, when the argument's a product, you can split it up into two logs with addition. Same thing when it comes to division, except this time you are going to split up the logs with subtraction. And then the last one is if your argument has an exponent, you can bring down that exponent and that will be a product with the log. All right, so this exponent now goes to the front and gets multiplied by the log. All right, so let's go ahead and just see some examples to get a little more comfortable with these three properties of logs. So for example, number one, it just says state whether each equation is true or false. All right, so based off of the property, I see I have a product here and I can split it up with addition. All right, so that's looking good. I'm just gonna double check my log base 5 is consistent. Log base 5, log base 5. So yes, that is true. All right. Number two, this one I have, my argument has an exponent, so I know I can bring this down to be 5 log base 2 of y, which is exactly what this one has. So this is also true. Okay. And then number three, I see that I have log base 4 of z plus 2, and then they made that log base 4 of z plus log base 4 of 2. Now we know this is not true because it has to be multiplication for us to be able to split it. Here it is just addition, so we cannot use the property. So this is false. All right, so this actually you cannot simplify, you would just have to leave it as that. So some students mistakenly do this. They think they can quote unquote distribute the log, but that is not okay. That is not the property. Okay. All right, I'll just show you one more bonus example here that has a little more to it. So I'll call this example 3.5. If I have log base 9 of x to the second, y to the third, over z to the fourth. All right, I want to go ahead and see if this is equal to 2 log base 9 of x plus 3 log base 9 of y minus 4 log base 9 of z. All right, so let's see if that checks out. Okay, so lots of properties, actually all three properties happening in this one. So first, I like to kind of just handle that division. So I know from the second property, the quotient one, I can split that division up using subtraction. All right, so if I were to kind of just work on that left-hand side, I know that this will be log base 9 of x squared y cubed minus log base 9 of z to the fourth. All right. And then using the first property, I can go ahead and split these guys up to be log base 9 of x squared plus log base 9 of y cubed minus log base 9 of z to the fourth. All right, so that again, product became multiplication. And now using the third property, I can bring these exponents all down. So 2 log base 9 of x plus 3 log base 9 of y minus 4 log base 9 of z. And I believe That is exactly what this one is. So that is true. All right. So I like that example because it actually has all three properties used in there. Okay, so let's go ahead and use those properties now to solve equations with logs. Okay. All right, so here I see I have logs in my equation. I have a single log on this side. I have two logs on this side. So I would say the first goal is to get each side just to have one log. All right, so I'm going to go ahead and I'm going to combine these two. Because it's addition, I know I can make that into one log with 4 times the 2x. So multiplying the two arguments together since it's addition. All right, so this is log base 5 of 8x is equal to log base 5 of 24. And then once you have just one log on each side, and they have the same base, you just need the arguments to equal for the whole equation to be equal. So I can just set those equal and just solve. All right, let's try one more here, number 5. Same thing, I want to get one log on each side of the equation. So I'm going to condense that. This is subtraction. So I'm going to bring those together using division. All right, and then once I have one log on both sides, I can focus on just setting those arguments equal to each other. Let's multiply 3 on both sides. Don't forget to distribute, subtracting the 3x, and then dividing the -1. Okay. And by the way, when it says the check your solutions, it's just to make sure that when you get your x, if you were to plug it back in, it doesn't make any of the arguments negative. We know that for logs, the argument a has to be greater than 0. So if you happen to get an x that, when you plugged it in, let's say it made it negative, you would actually have to toss that solution. So that's why it has this check your solution hint in the directions. Okay, let's go ahead and try it with number 6 and 7. If you think you got it, feel free to pause the video, try 6 and 7 yourself, and then just check your answer once you're done. If you're not quite there yet, that's okay. I'll go ahead and just explain 6 and 7, and so you can have a few more examples under your belt. All right, so number 6, to get this to just be log, I'm going to bring up the exponent over the argument. All right, so this is going to be log base 4 of x plus 1 squared. All right, so I can set these arguments equal. I'll go ahead and FOIL out the x plus 1 times the x plus 1. So that's x squared plus 2x plus 1. And since I have a quadratic, I'm going to go ahead and solve by getting everything to one side and making sure that's equal to 0. All right. I think this is factorable, so let me defoil this. So I have, when I cross multiply and add, I do get my 3x. X times x gets me that x squared. 5 times -2 gets me that -10. So this factors out, which gets me x is equal to -5 and +2. Okay, so let's check and make sure nothing goes negative. The -5, when I plug it back to my original, there it is. When I plug it back into my original, it actually does make my original argument negative. So I'm going to need to toss this answer. Okay, so remember, it's the original problem you want to plug into. So when I plug in -5, all right, this goes undefined. So can't keep that one. This one, when I plug it in, it's okay since both of those arguments are positive. So final answer will just be x is equal to 2. Okay, and feel free if you want to write notes to yourself. You can say tossed or crossed out since it makes the original argument negative. All right, and then number 7, I'll go ahead and combine these two. Since it's subtraction, I'm going to use division to combine those arguments. All right, and then once I have logs on both sides, I can just set those arguments equal. All right, I'll multiply up the 4c minus 1 on both sides to get rid of that fraction. Distribute, subtract, and then divide. I get 8 over 19, which, let me just double check. When I plug it back into the original, that one's still positive. That one is also still positive. So that would be my final answer. All right. Cool. So that's how you use those properties to solve for log equations. Again, generally the step is just get single logs on both sides with the same base, and then you just set your arguments equal and solve. Okay, let's try the last type of problem. So these, they want you to find the value of these logs, and they give you just these two. So you're supposed to do this without a calculator. So they just give you these two, and you need to use that to get to log base 12 of 21. All right, so for the first one, I see I have an argument of 3 and 7. So I can see that I can get 21 pretty easily by just multiplying 3 and 7. All right, so I'm going to rewrite this as log base 12 of 3 times 7. So since the argument is being multiplied, I can split that up using addition. And now just substitute with the decimals they give me. Okay, and then I'll just add those together. I get 1.2252. Okay, and that's it for number 8. All right, number 9. 49 I can get by squaring the 7. So I have log base 12. I'm going to replace 49 with 7 squared. And using the third property, I can bring down that 2. So this is 2 times log base 12 of 7. So 2 times that decimal. All right, and then that gets you 1.5662. Okay. I'm going to save number 3. 3 is a little bit of a challenge, so I'm going to save that one for a little bit later, give you a chance at it first. Number 11. Number 11, I can see I still have that 49, and I have that 27 up top, which is going to be my 3 cubed. All right, so let me rewrite this one. So log base 12, this will be 3 cubed, 7 squared. Okay, and then let's split that up. And I have log base 12 of 3 cubed minus, since it's division, I'm going to subtract when I split. And then I'll bring down that exponent, bring down that exponent, like so. All right, and then I'm going to replace those with the decimal, so 3 times 0.4421 minus 2 times 0.7831. All right, so that's going to get me 362, 1.3263, I believe, minus 26615. And I am double checking with my answer key, lest you think I am doing this completely in my head. That is not true. Okay. All right, and then that is a negative point. Let's see, 9, 9, so 5, so 3, 1. No, 2. Yes. Okay. All right. So that is number 11. Okay. Number 12. Again, if you at any point you feel like you got it and you want to just pause the video, try it yourself, and then just fast forward the video to check your answer, feel free, kind of use this video to your advantage. And that you can pause, fast forward, rewind. Yeah. All right. So number 12. I'm going to break down that 441. That's a special number. That's 21 squared. So 21 squared. And how I'm going to get that 21 is I'm going to use my 3 times 7. There you go. All right. So from there, I can bring down the 2 using that third property of logs. And then now I'm going to split this up. Now, careful here. This is 2 times the whole thing. So this is going to be 2 times log base 12 of 3 plus log base 12 of 7. All right, so I'm going to put parentheses around that whole thing because I know I'm going to be 2 times that whole thing. All right, so this was 4421. This was 7831. And this time I'm going to add those together first. And then I'm going to multiply. 0.542. All right, so 2.4504. Okay. So the challenge one, number 10. Again, if you want to try yourself first, give it a shot. This one's definitely tougher because it's hard to get 36 with these numbers that you have. So you kind of have to think a little bit outside the box here. So I'm going to go ahead and go through it. 36. I can see the factor of 3, which I like because I have log base 12 to the argument of 3. But the 7 doesn't seem to go into that 36 pretty nicely. So what I would do is I would actually break this up to be log base 12 of 12 times 3. Well, that's true. 12 times 3 does get me back to that 36. And the reason why that's okay to use is because we don't need a calculator to tell us what log base 12 of 12 is, hopefully. All right, so I'm going to split that up using the property, right? I'm going to add those logs because it's multiplication. And hopefully from the previous lessons, you know that log base 12 of 12 is 1. Because log asks the question, 12 to what exponent gets me 12? So 12 to the first exponent gets me 12. All right, so you have other numbers you can play with besides just the arguments of 3 and 7 that they give you. Okay, so this is 1.4421. All right, so that's kind of the third type of problem you might find. Number 13 is just kind of giving you a situation, a context in which you might see problems like this. This is talking about the loudness, L of sound in decibels is given by this equation. R is the sound's relative intensity. If the intensity of a certain sound is tripled, by how many decimals does the sound increase? All right. So if the certain sound is tripled, like let's say my original sound R was just 1, my new R would just be 3. All right. So then here, I know that this is going to be log, or 10 times log base 10. Oh, sorry. Oops. This would just be log base 10, 3 to the 10th power, which we can do in our calculators, or well, technically you could have just done the calculator straight from there. So really, using your calculator, get that either way. You would get 4.8 decibels. All right, so just to give you a little bit of context that you might see logs in. Okay, that is it for the lesson. Good luck.